Hey everyone, moving on to the second part of our integration by parts video, we have the technique where instead of obtaining the final integral at the end, we would need to do some manipulation before we achieve the integral. So what do I mean by that? Well, first let's recall the formula, right? We have u prime v dx equals to integrate one minus sign differentiate the other. Alright, so let's look at the example first. We have ex sine x dx. So clearly we have one exponential times one trigonometry. There's no direct way to integrate this, and there's no substitution, right? Once an exponential, once a trigonometry, there's no substitution that could help you with this. As such, we'll use integration by parts. So commonsensically would tell you that you want to integrate ex first, right? I mean, there's no argument about that. But you realize that you can also integrate cosine first because it's a repeating function. Sine becomes cosine, then cosine integrator will give you back sine. So, well, technically it can go both ways, but let's just follow the rule like it. So we integrate exponential first, which is also exponentially easier. Integrate exponential gives us back ex, then we get back sine x. Now we differentiate the other, so we get cosine x dx. Sine x becomes cosine x. Now what do? Well, we realize we are still not done yet, so what do? We perform integration by parts once more. Okay, then we get, now we integrate 1, so we integrate ex again to give it back ex. Now, don't forget, we differentiate the other. So when we differentiate the other, differentiate cosine x gives us back minus sine x, so minus minus become plus sine x dx. And then you realize, wait a minute, we just obtained the integral that we wanted to have. If you notice, we get ex sine x on the right again, and it's a minus sign. What do? Well, we bring this over. So now we know we get 2 ex sine x dx equals to ex sine x minus cosine x. And therefore, we achieve to this conclusion where integral of ex sine x equals to half ex sine x minus cosine x. So there we have it, where we use integration by parts, but instead of obtaining the answer directly to the end, we have to do some manipulation because we will obtain the integral that we want to in the second part of our integration by parts. To continue the same example, I'll show you that you'll be able to obtain the same answer by integrating sine u first. So if we integrate sine u first, we will get ex cosine x, sorry, this is x, whatever u, ex cosine x first, because if we integrate sine x, you get minus cosine x because sine has an n and is negative. Minus sign bring over become minus sign, so minus minus become plus. Now I differentiate ex to give me back ex cosine x. Then we realize we have to do it once more. So we integrate cosine x first. So integrate cosine x to give us back sine x. Now we differentiate ex to give us back ex again. Then you notice we will get back the same derivative, and then we perform the same thing where we bring this over and then we divide by 2. One thing to take note is that in integration by parts, right? So let's say you've integrated, let's say it's u prime. Let's say you integrate u prime to u, right? Then you differentiate v prime now. So you differentiate v now to obtain v prime dx. You cannot now, okay, you cannot like, now, okay, now I do it the other way around, right? Now I integrate v prime, then I differentiate u prime. Then you realize, hey, I get back the same answer. Okay, so clearly you just did a loop, right? You cannot just integrate one, then differentiate the other, then you obtain another integration by parts, then you, okay, now how about I try integrating the other one now? Then you get back to the same original integral, which, doesn't help, it doesn't make sense either. Alright, so yeah, this will conclude integration by parts.